Yes, in the previous lecture session, we had studied computer instructions. Okay, I had explained you that there are three different types of instructions. First one was memory reference instruction, second was register reference instruction, and third was input-output instructions. Okay, excuse me. What was the difference between these three registers, these three instructions that we studied? Was the instruction format. Okay, first of all, we studied what is instruction register. It holds the instruction. Instruction is a 16-bit long binary word. When we talk about a particular instruction, it is represented using 16 bits, right? And this 16-bit instruction is stored in IR. All these we have already covered. We had also seen the instruction format where the first bit stands for memory reference, where the first bit I is a flip-flop which decides whether my instruction is direct, which stores direct address or indirect address, right? After that, we have opcode, which is the remaining 3 bits. So first 4 bits over here, leftmost 4 bits, indicates whether this 15th bit is direct indirect mode. Then 12 to 14 is your opcode, and remaining 0 to 11 is your address. Okay, this was for what? This was for memory reference instruction. Then we saw that register reference instructions have fixed 0 in I bit and fixed 111 in opcode. Okay, and here we do not have addresses, but this part 0 to 11 refers to the register operations. We'll be discussing each and we have already discussed each and every operation, but we'll go through that once again and then we'll move ahead. Okay, and for IO instructions, 15th bit is 1. This is 111 and 0 to 11 stands for other IO operations. Okay, so these are the three formats 1, 2 and 3 which we had already studied in the previous class. So now whenever any instruction is given to you, we had also seen this list of instructions last time. And add load accumulator, store content of accumulator in memory, branch unconditionally, branch and save return address, and increment and skip if 0, all these are memory reference instructions. Okay, how did we get to know? See, first of all, when we say that this is my 16-bit instruction format, I'm dividing it into 4 parts. Okay, 16 bits, so I have divided it into 4 parts. We saw that the first 4 bits are for opcode and the I bit. For register reference instruction, what did we say? That the first bit is 0 and remaining 3 are 1. For input output instructions, we saw that the first bit is 1, remaining 3 are 1. Okay, so if my instruction starts with 7, 0, 111, it means what? It is a register reference instruction. पीछे कुछ भी हो सकता है. Okay, it can be anything. If it is 0, 0, 1, this bit would be 1. If it is like this. Okay, so this is an instruction, but if the instruction is represented through hexadecimal 7100, it means this is a register reference instruction. Similarly, if my instruction starts with F, we know that 1111 is 15 and 15 is represented with F. फिर वो पीछे अब कुछ भी हो, you should be immediately getting to know that this is an input-output instruction. Okay. For memory reference instruction, we saw that my first bit can either be 0 or it can be 1. And opcode bits would range from 0 to 6. क्यों? क्योंकि 111 is fixed for register and IO. Okay, so these 3 bits would range from 000 to 110. Fine. So for 0 to 6 and 8 to E, if my instruction starts from 0 to 6 or 8 to E, 7 and F are reserved for register reference and input output reference. Okay, so if my instruction starts with this, it means it is a memory reference instruction. Itna clear, all of you? Yes or no? The three types of instructions. Okay, fine. Now, how are these instructions formed? So here we said that these three bits, these three groups of 4 bits each, yani 12 bits, okay, 0 to 11, all these are for addresses. So in this, I need not explain to you anything else. You should remember this sequence ki pehle AND aata hai. It means if my instruction is 0 something something, it is an AND operation. If my instruction starts with 1, it is add operation. And in exam also, you'll be asked like that, okay? You may be given a specific instruction like this, kuch instruction diya hoga, and you will have to specify that which instruction is this. You should be knowing ki yahan pe 0, 1, 100 is what? 4. 4 means this is a branch unconditional instruction. Okay, so you should remember this. Category you will remember through logic. If it starts with 7, it is register reference, 0 to 6 or 8 to E, memory reference. But ये आपको याद रखना है कि first is AND, then add, then load accumulator, then store content of accumulator in memory, branch, unconditional. We'll be seeing the operations involved in each and every instruction later. Okay, but right now you should be knowing the list of all the operations. Fine. And if you know the sequence, you'll be able to write its instruction code, hexadecimal code on your own. Okay, let me show you one or two examples from here. Suppose I say that CLA. How is this CLA designed? CLA is clear accumulator. Whatever is the content of your accumulator, you are asked to clear it. And this is a register reference instruction. Okay, so we know that register reference instruction starts with 0111. Now, what we will do is remaining 11 bits are for register operations. हमने क्या लिखा था वहाँ पे? We had written register operations. Initially, all these are zeros. Okay. Now, when we want to frame the first instruction, what we will do is we'll place 1 over here. Remaining would be 0. So, ये क्या हुआ? 7, 8, 0, 0. This is how we got the instruction clear accumulator. Second, when we say is CLE. What does CLE mean? We know that we have an extra bit E available. What is it E used for? आगे हमने देखा था. ठीक है, it is a extra flip-flop, extended flip-flop we would say, extended flip-flop for our adder and logic unit. So for any type of carry or borrow, we use this E. So when we write the instruction format for CLE, here 0111 would remain the same. Now we will make this second bit 1. Okay, and then remaining would be 0. So now what would be the code for CLE? It would be 7200. Check it out. Is it 7200? Sorry, this is not 2, it is 4. It's 7400. Okay. So did you understand how are these codes generated? So when you are said that 7004, if you are specified 7004 in binary format, you should be knowing what is that instruction for. And that you can only remember if you remember the sequence of these operations. Okay. I'll quickly let you know. First is clear accumulator and clear E. आपको automatic याद रह जाएगा. Then comes complement accumulator, complement E. Okay, whatever is the content of the accumulator, complemented. Whatever is the content of E bit, complemented. Then comes circular shift right and circular shift left. Fine. Again, look at this 7080. What does that mean? Which bit changed? यहाँ की 3. This one is for, this bit is for clear accumulator. This is for clear E. This is for complement accumulator. This is complement E. Now comes the next instruction, which is circular shift right and circular shift left. So if this is 1, it is circular shift right. If this is 1, it would be circular shift left. Okay. Then what is this? SPA. Now there are certain instructions which help us to check depending upon the value of accumulator, carry out this instruction, carry out this step. What does this mean? When I say skip SPA, skip next instruction if accumulator is positive. What does skip next instruction mean? We know that we store our instructions in our program counter. So when we say that when value of accumulator is positive, skipping an instruction means you increment the value of your program counter. So what would it do? It would skip the next instruction and move to the next instruction. Okay. Similarly, the next instruction is SNA. SNA stands for skip the instruction if accumulator is negative. N stands for negative. P stands for positive. Okay. So SPA, SNA. Z here stands for 0. Skip the next instruction if accumulator is 0. Similarly, skip the instruction if E is 0. याद रह गए? First one, CLA, CLE. Then complement accumulator, complement E. Then comes circular shift right, circular shift left. ठीक है? After that, increment accumulator. Okay, this I had skipped telling you. After that, the remaining 4 instructions are skipping instructions, once when accumulator is positive, once when accumulator is negative, once when accumulator is 0. And third one, when E is 0. So as a step by step आप याद करोगे, तो you will remember all these instructions. Okay. Similarly, for input-output instructions, look at that. The first bit, first group of first hexadecimal value is F. Why? Because all the 4 bits, first 4 bits, that is most significant 4 bits are 1. Okay. And then the same logic, 1, 1, 1, 1. उसके बाद ये जो next 4 का set है, उसमें एक को 0 रखो, sorry, एक को first को 1 करो and remaining all zeros. Okay. So this is F800. F800 is input instruction. That is, whatever input you have received, input that character to accumulator. Then whatever value is stored in the accumulator, output that character to the output device. That is the out instruction. Okay. Similarly, I'll tell you about this halt instruction later. Okay. SKI is there are additional flags available for controlling the input and output. Those are your input flag and output flag. So skip when input is 1, input flag is 1, skip the instruction when output flag is 1. Okay, we will be using all these instructions. We'll be seeing which are the set of micro operations involved in each and every instruction in the next section. Okay, and last one is interrupt on and interrupt off. We'll study interrupt, what is interrupt in detail in the upcoming sessions. Okay, so these are the 3 different categories of instructions which we covered. Now, see, unless and until you refer to this table and again, you will not remember the instructions. Sir. So please make sure that you recall, you memorize these instructions, the order of these instructions, format you know now. Okay. So, and it won't take much time. You will remember it. Abhi register reference to sari yaad rahege kyunki I explained you one by one. Okay. Chalo. Now, talking about instruction set completeness. When can I say that? When can I say that what is the minimum requirement for designing the instruction set for designing a basic computer? Which are the basic instructions required for designing this basic computer? Okay, which are the basic minimum requirements of instructions in my instruction set? Just hold on. So I can say that my instruction set is complete if first of all, I have all my arithmetic, logic and shift instructions involved. Okay, सारी ये ALS instruction आ गई. Second, my instruction set should have instructions for moving information from and to memory. Like I should be able to read instructions from memory, read information from memory, and I should be able to write information to memory. Okay, you have instructions like LDA, STA. What is this? Load accumulator from memory. Store the data in accumulator to memory. So here we have such instructions which help us to read information from memory and write information to memory. So this type of instructions should be there. Next, we should have some instructions which are program controlled, right? Which help us to check the status condition. Check status condition. Depending upon a particular status, you need to carry out the instructions. Like we had seen skipping instructions, branching instructions. Branching is nothing but you're jumping from one location to another. Just hold on. Yeah, sorry. Fine. So, I can say that my instruction set is complete if I have all my arithmetic, logic, and shift instructions. I have all the instructions related to loading and storing to memory, that is fetching data from memory and writing data to memory. Then I should have some instructions which help me to skip or jump to particular instruction, particular location, and finally input output operations. Okay, so all these would consist of the complete set of instructions which are required for designing a basic computer. Okay, now we'll be moving ahead and seeing the control organization, timing and control. Okay. So see, the timing for all the registers which are included in our basic computer are controlled by a master clock. Okay, we need some clock for synchronization. Okay, so for this timing and controlling the operations, we need a control unit. A control unit is required for this synchronization, for this timing and control decisions of the operations that are to be carried out. Okay, now this control unit can be designed by two ways. One is hardwired control, and second is it can be microprogrammed. Okay, so hardwired control or microprogrammed control. See, what are we doing right now? We are designing a control unit which would include the timing sequence, timing for controlling the operations. Okay, so it can be done using two ways: hardwired control and microprogram control. When I talk about hardwired control, it is implemented with the help of gates, flip-flops, then decoders, okay, and other digital circuits. Whereas when we talk about microprogrammed control, here what we do is we write a control program. Let us first discuss about hardwired control. So when I have all the hardware gates and all hardware gates, flip-flops, decoders available with me in my circuit, it provides optimized, that is faster mode of operation. Okay, all my operations would be carried out in a faster way. But what is the drawback over here in hardwired control? Whenever I require any changes in the wiring of components, I'll have to design it. I'll have to make lots of changes. Why? Because I have all my physical components over here. Fine. So it is complex to modify. Whereas talking about microprogram control, here the control information कि कौन से टाइम पे क्या एग्जीक्यूट करना. So this control information is stored in the control memory. Okay, it's stored in the control memory, and this control memory is programmed to initiate the sequence of operations. उसमें there's a program written that which instruction to execute when. Okay, so this control memory is programmed to initiate the required sequence of micro operations. So here, what is the advantage? It is actually less faster compared to hardwired control, but the advantage over here is whenever any changes are required to be done in updating the microprogram, all you have to do is just change your program which you had written. In that, only the sequence of operations can be changed. Okay, so this microprogram control we are going to study in chapter number 7. But in this session, we are going to study about hardwired control. Okay, let us now see this hardwired control and see how to design the control unit. So for studying the control unit, let us first quickly recall our instruction register. In our instruction register, we have total 16 bits, right? 0 to 11 is my address. 12, 13, 14 is my opcode, and this is your 15 bit, which is your I bit. Now, first of all, we will need control and logic gates. We are designing a control unit. Okay, so here we will need control logic gates, to which we will be providing some control input, and accordingly it will generate control output. Okay, for this we will need a 4-bit sequence counter. Now what is this sequence counter? We will need a counter which would help us to generate the timing signals. एक counter चाहिए, this is time 0, this is time 1, this is time 2. So automatically your timing signals should increment, right? Once one timing signal, timing signals, आपने कहा कि we have at different timing signals, different operations take place. So we have different timing signals like this, T0, T1, T2, T3. So what will I need over here? For generating this sequence of timing signals, I'll need a counter. And what is this counter called? We will call it sequence counter. Okay, this sequence counter again will have 3 signals. कौन कौन से signals होंगे इसमें? One signal is nothing but your increment. Why? Because I'll need to increment the timing signals from 0 to 1, 1 to 2, 2 to 3. Then I'll have a clear signal. कोई भी counter है तो counter के अंदर क्या होगा? You will have a clear signal which would help me to restart my counter starting again from time 0. Okay, and third signal, I'll be having my clock, which will help me to increment this counter at regular time intervals. Depending upon the frequency of my clock, it would change the timing signal from T0 to T1, T1 to T2, like that. Okay, now this 4-bit sequence counter is provided as an input to a 4x16 decoder. When I provide this this is a 4-bit counter. Okay, so it is capable of generating how many different timing signals? T0 to T15. ठीक है, इतने टाइमिंग सिग्नल्स ये जो भी है आपका सीक्वेंस काउंटर, it would generate with the help of a decoder. So these are your timing signals. Okay, so all these T0 to T15 timing signals are provided to your control logic gates. Okay, so if I want to say that T0 पे ये काम होना चाहिए, तो यहाँ पे T0 की वैल्यू चेक करेगा. If the value of T0 is 1, then whatever instruction I have specified would be executed. Okay, so this is, you are providing all T0 to T5 timing signals to your control logic gates. Apart from this, what else will I have to provide? 0 to 11. These bits I'll be providing directly. ठीक है, it can be address, it can be register instructions, it can be input output instructions. ये हमने तीनों फॉर्मेट आगे पढ़ ली. Okay, so these 0 to 11 bits are directly provided to your control logic gates. Apart from this, these 3 bits would again go to a decoder. 3 bits, so 3 cross 8 decoder. What is it for? It is used for decoding the instruction. कि ये कौन सी instruction है? Okay, so this 3 cross 8 instruction here, you will be generating D0 to D7 different instructions, right? So again, all these outputs of your decoder, from this you will be able to decode which instruction is required to be executed through the opcode given over here. So all these 8 instructions, D0, D1, D2 up to D7 would be provided again to the control logic gates. And this last bit is stored in a flip-flop I, and this is also provided to your control and logic gates. So now if you have all these information available, will the instruction be able to execute? ये वाली value direct provide कर रहे हैं. This we are decoding it and providing it to the control logic gates कि मुझे क्या करना है, मुझे D0 देना है, I की value 1 है, then if this is D7 it means 1 1 1 जा रहा है, I1 जा रहा है, तो it would get to know कि which type of instruction it is, and depending upon the timing signal what we will be specifying, this particular instruction would be executed. Did you understand this figure? Step by step, what did we do? We first provided all the timing signals to the control logic gate. Then we provided this part directly to the control logic unit. These 3 we provided after decoding it to the control logic. Okay, so 8 signals from here, 16 from here. This 15 bit individually we provided to the control logic unit. Okay, so now let us see the figure here, neat figure over here. This is what is explained. Okay, so you will, this is your decoder for sequence counter is important over here. This sequence counter would generate timing signals T0 to T15. Then this decoder helps us to decode the instruction, right? And all these inputs, as we discussed, would be provided to your control and logic gates. Clear? Now let us see. Suppose I say that like this, wait. When I have an instruction like this, D3, T4, SC0. What does this mean? I will be clearing my sequence counter SC when D3 is 1 and T4 is 1. At timing signal T4, if D3 is also 1, clear the sequence counter. Okay, so now if I want to represent this using a timing diagram, how can I do that? These are the different instructions, T0, T1, T2, T3. First T0 will be 1, then T1 will be 1, then T2 would be 1, T3 would be 1. Here T4 would be 1. Okay, so at this particular time D3 instruction is not there. But when the value of D3 is 1, both these T4 and D3, both of them are 1. यहाँ पे भी 1 है और इधर भी high है. So at that time what would happen? The clear of sequence counter would be set to 1. Okay, so this is how your processing would take place. Understood? So here, one by one, we will see how are these instructions executed. But this is just an example that what is, you will get to know how is this timing signal, how does the timing signals work when we start off with the instruction cycle. पहले ये diagram अच्छे से समझ में आ गया आप सबको? If you are asked to design the control unit of basic computer, will you be able to draw it on your own now? All of you. I want all of you to be with me. If you have understood this, you will be able to draw it on your own now without looking here and there. Okay. Fine, good. And you understood this timing signal as well. Okay, मैंने आपको जो बताया T0, T1, T2, T3, and when you clear the sequence counter, it would again start from T0. Okay, chalo, now let us move to another important concept, which is So every computer has this type of control unit, okay, which helps in generating different timing signals, and taking into consideration these timing signals and the instruction that you provide, your control logic gate would decide what type of control output to generate and where to pass these instructions to. Okay, now let us talk about any instruction cycle. Whenever, a program which is residing in your memory unit, it consists of a sequence of instructions. Okay, when we talk about these instructions in a basic computer, these instructions are divided into following phases. Which are those phases? First one is fetch the instruction from memory. When you want to execute some instruction, you need to first fetch the instruction from the memory. So that is the first part. Second part is you need to decode the instruction. Okay, whatever instruction is there, you need to identify what type of instruction it is, whether it is memory reference, register reference, or input output instruction. You also need to identify or read the effective address. If it is an indirect address, you have to read the effective address from memory. यानी वापस आपको memory को refer करना पड़ेगा. Okay, so you need to refer the effective address from memory if it is indirect address mentioned. Okay, and last step is execute the instruction. So these are the 4 steps which are involved in any type of instruction cycle. First, you need to fetch from the memory, then you need to decode it. Okay, now if I specify these steps in register transfer language, let us see the fetch and decode step first, okay, in detail. Fetch and decode. This is the first 2 phases, okay. First of all, whenever I want to fetch some instruction from memory, what do I need to do? Who will tell me? Where would you fetch the instruction from? You need to fetch the instruction from memory, right? But कैसे पता चलेगा कि कौन सी instruction fetch करनी है, कैसे fetch करनी है? Where are our instructions stored? Yes, they are stored in the program counter. So what will you do? Program counter के अंदर instruction पड़ी है, ठीक है? So here PC is loaded with the address of the instruction to be executed. Now how are you going to fetch that instruction? What will you have to do if you want to fetch those instructions from that program counter? Where will you fetch it and put it to? क्या प्रोग्राम काउंटर में इंस्ट्रक्शन है आपकी? ओके, तो उसको फेच करके कहाँ रखोगे? आईआर में रखोगे? सीधा आईआर में would you connect your PC with IR accumulator? ना. PC के अंदर इंस्ट्रक्शन है तो सबसे पहले क्या करना होगा? At timing signal 0, you have to first fetch the instruction. Instruction आपको instruction के अंदर address भी होगा, right? So what you need to do is PC का जो भी content है, first you pass it to the address register. Why? Because address मुझे क्या करना होगा? वो वाले address register जो भी है, वो वाले data मुझे memory में से fetch करना है. Okay, so what we will do is we'll first transfer our instruction from PC to AR at timing signal T0. Then comes what you were saying. You need to store your instruction. You need to store your instruction in what? In your IR. ठीक है? तो वो instruction आप क्या करोगे? From memory address AR में जो भी address है वहां से आपको fetch करनी है instruction. Okay. PC, what would PC consist of? PC consists of which instruction you need to execute. But where would that instruction be actually? It would be in memory. You need to fetch that instruction from the memory. PC would store कि कौन सी instruction access करनी है. Okay, it consists of the address of the instruction. So that instruction address is first stored in address register. From memory, at that particular instruction is fetched and it is placed in IR. Okay, यानी अब पीसी का काम खत्म हो गया, पीसी के अंदर अभी जो इंस्ट्रक्शन थी वो इंस्ट्रक्शन हमने फेच करवा ली. सो व्हाट वी विल डू इज नाउ पीसी वुड बी इंक्रीमेंटेड टू, इट वुड गो टू द नेक्स्ट इंस्ट्रक्शन. ओके, यहां से फेच हो गई इसलिए हम पीसी को भी इंक्रीमेंट कर सकते हैं. नाउ पीसी वुड बी हैविंग व्हाट, इट वुड बी स्टोरिंग द एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन. इतना क्लियर? दिस इज व्हाट, दिस इज योर फेच फेज. फर्स्ट you are fetching data from PC, storing it into address register. This address register can be accessed by memory for read purpose. Okay, so memory, you are reading that particular instruction and storing it to IR. That instruction now is in your instruction register. So now PC should be made ready for the next instruction. So PC is PC plus 1. So at time T1, these two operations would take place. Okay, and at time T2, what would happen? Instruction IR में आ गई. Now what you need to do is you need to decode this instruction. Decoding कैसे होगा? तो D0 to D7 is decode आप जो करोगे, that decoder 3x8 decoder जो था, okay, what would it do? It would decode the 12th to 14th bit and store it to D0 to D7. Okay, along with it AR के अंदर क्या स्टोर होगा? IR की 0 to 11th bit. Why? Because it can be address, it can be instruction format. हमने पढ़ा ना 0 to 11 के अंदर क्या हो सकता है? Address होगा if it is a memory reference instruction. Register operation होंगे if it is a register reference instruction, या input output operation होंगे if it is input output instruction. So where do I need to store the 0 to 11 again? To my AR. Okay, so 12 to 14 bit decode होके D0 to D7 में जाएगी. They are decoded. Okay, then this IR 0 to 11 would be stored in AR, and my last bit instruction register की 15th bit would be stored in flip flop I. So this is your decode phase. हमने क्या किया? IR को break किया बस. You all know what is breaking of your IR. 0 to 11, store it in AR. Decode the bits and identify whether it is D0, D1, D2, D3 up to D7. Okay, and last bit, most significant bit, store it to I. Fine, इतना पता चल गया सबको? All of you? Good. अब T3 पे क्या होगा? So at time T3, your control unit would decide, would identify which type of instruction it is. Okay, it would, control unit would determine the type of instruction. हमने decode first T0, T1 से क्या हुआ? Fetch हुआ. T2 से क्या हुआ? Decode हुआ. Now T3 would, what would at time T3 happen? It would identify whether it is a memory reference instruction, whether it is a register reference instruction or input output instruction. Okay, so at time T3 it would be decided. Now how to decide it? Let us simply design a simple flow chart. Okay, एक फ्लो चार्ट के थ्रू हम डिसाइड करेंगे कि ये इंस्ट्रक्शन कैसी है, कौन सी है. So first of all what we will do is we will start, and we'll start with our sequence counter to be 0. Okay, what was my first operation? प्रोग्राम काउंटर में जो भी है उसको कहाँ डालो? AR में डालो. ठीक है. After that, so this was taking place at time T0. After this step, what did we do? In our IR, we placed this, we read the word from memory location AR and we placed it into IR. And along with this, what did we do? We incremented the program counter as well. So this entire operation takes place at time T1. ये ध्यान से देखना और you will understand this flow chart if you have understood the entire process. Okay? T1 हो गया. T2 में हमने क्या किया? Decoded. ठीक है, पूरा जो मैंने अभी ऊपर लिखा था D0 to D7 वाला, and AR के अंदर हम क्या करेंगे? IRs 0th to 11th bit, and in I what will we transfer? We'll transfer 15th bit. Okay, so this much is done. Now how do you identify which type of instruction is it? Tell me, what will we check to identify whether it is a memory reference or register reference or input output reference instruction? Which bit do I need to check? MSB नहीं, हमने पूरा decode कर दिया. Now what do I have? I have D7 to D0. I have data in AR and I have I bit. Yes, you need to check D7. You need to check D7. I को check नहीं करना है, पहले D7 को check करना है. Why? Because we know that for memory reference it would be from 0 to 6. For remaining two type of instruction, you will have, when you decode this, you will have value 7. So depending upon the value of D7, you will be able to identify which type of instruction it is. Okay, so if the value of D7 is 1, it means what? It is either register reference or input output instruction. Okay, if D7 is 1, it means it is either register reference or input output instruction. क्यों? Because register reference में यहाँ पे 3 1 है. Input output instruction में भी D7 1 है. Okay, so now after that what will I check? कि ये कौन सी है? Yes, I need to check my I. If I is 0, तो क्या? It would be a register reference instruction. See, if I is 0, what will we do? Execute register reference instruction and then make SC 0. And if I is 1, it would be my memory reference instruction. Sorry, memory nahi. Input output. Input output instruction and make SC 0. That is start again. Okay. So this thing would take place at time T3. उसने identify किया कि कौन सी instruction है, तो उस time पे आपकी register reference या input output instruction execute हुई. What if D7 is 0? It is a memory reference. But अब क्या करेंगे? इसमें भी we need to check something. What? We need to check I. If the value of I is 1, it means if it is indirect addressing mode, तो क्या करना पड़ेगा टाइम T3 पे? Who will tell me? If it is indirect address, then AR के अंदर MAR. Yes, whatever is it right now in MAR, that would be the actual effective address of my operand, and that we need to store it in AR. Okay? And if I is 0, तो मुझे कुछ नहीं करना है. Why? Because my operand is the same. Okay, my operand is there in the instruction itself. And after this, what we will do is we will execute our memory reference instruction. Understood the entire flow chart? After this particular, यहाँ पे भी जैसे ही once you execute the memory reference, again set the sequence counter to 0. So after this, it will go back to AR, fetch data from PC to AR. Okay. Step by step, I had drawn the flow chart and explained you. Just have a look at this. ये मैं बाद में आपको कल सिखा दूंगी. I forgot to explain this diagram. Yes. So this is your flow chart. Initially, start your timing signal with 0, and to start with T0, what you need to do is clear the sequence counter. First step, fetching phase. Program counter से AR. Then from AR, fetch the instruction. At location AR, you will be having that instruction. So from memory, you will fetch that instruction and store it to IR and increment the program counter. Next step is T2 signal पे क्या होगा? Decoding. Decoding first 12 to 14 bits, D0 to D7. Then 0 to 11, store it in IR. 15th bit, store it in I. Depending upon D7, you will be able to identify whether it is register reference instruction or memory reference instruction. Okay. If D7 is 1, it can be either register or IO. Again, it depends upon the I flip-flop. Okay. If it is 1, execute input output instruction. and again start your SC with 0. If I is 0, execute register reference and set SC to 0. Similarly, यहाँ पे हमने देखा, if it is indirect mode, again I need to change my AR. AR is not having the actual address, is not having the effective address. Okay, so what I need to do is, again from memory address of AR, fetch the data and store it to AR. That would be your effective address. Okay, and once this is done, यहाँ पे T4 नहीं लिखा है because it's not necessary for all the memory reference instructions would be executed in a single time sequence. Okay, तो यहाँ पे T4, T5, T6 भी आ सकता है depending upon that memory reference instruction. We'll be studying each and every instruction in detail. Fine, and after this, all the instructions are executed again. Where is the arrow going back? It's going to timing signal T0. Did you understand this? This process will keep repeating until a halt instruction is received. Fine. So this is how your instructions are executed. This is the cycle: fetch, decode, and then execute on the basis of which type of instruction it is. Is this instruction cycle clear to all of you? I want to answer from everyone, not just a few students. Okay, fine. Do you have any doubt in this? We studied hardwired control unit. Hardwired control unit would have a sequence counter for generating timing signals, and then we saw that using these timing signals, how is an instruction executed? What is the cycle in which an instruction gets executed? Okay. Chalo, we'll continue. We'll see more examples on this. We'll be actually seeing the different instructions in the form of timing signals, how to represent them using at different timing signals in the next class tomorrow. Do refer to this once, okay? And then when I say D7I, तो you should immediately identify which instruction it is. वो तुरंत strike हो जाना चाहिए. तो वो table जो मैंने आपको बोला, एक बार अच्छे से refer to it, and you will be able to remember all those instructions. Okay? चलो, I'll be ending the meeting now. If you have any doubts, you can ask me.